Welcome to the technical interview, where we make complex tech topics easy to understand. Today, we are navigating the world of concurrency and synchronization. If you're gearing up for a tech interview or just want to learn more about how computers work, you're at the right place. Let's get started. Let's start with the formal definition of concurrency. Concurrency is the ability of the computers to deal with multiple tasks and do them at once. It's like having several balls in the air while juggling them without letting any of them fall. These tasks could either be through one application and one process or across multiple applications and multiple processes. Now, let's simplify concurrency with a real-world analogy. Imagine you're in a kitchen with 4 burners, each capable of cooking a different dish. This is your multitasking setup. In the computer world, having multiple processes allows your system to handle different operations concurrently, similar to cooking multiple dishes at once. So, what is synchronization and why does it matter when doing concurrent processes? Synchronization in computing ensures that the concurrent processes do not interfere with each other while interacting with shared resources. To go back to our kitchen example, it's a bit like ensuring that each chef in a busy kitchen can access ingredients and utensils without clashes. Imagine a scenario in our kitchen where we have one salt shaker, but both soup and sauce that need seasoning. Without a system, 2 chefs might reach for the salt at the same time, leading to a conflict or overly salted dish. Synchronization tools in computing, like locks, semaphores, are the rules of the kitchen that prevents these mashups. They ensure that only one process can access a particular resource at a time. Now that we understand the importance of synchronization, let's dive into a few tools that help us achieve it. Different mechanisms are used depending on the complexity and requirements of the task. We are going to explore 3 synchronization topics: locks, atomic operations, and condition variables. First, let's talk about locks. A lock is a mechanism that controls access to a resource by multiple threads. Think of a key to a single bathroom in a large house. If someone is using it, they lock the door and no one else can use it until the door is unlocked. In computing, locks prevent other threads from entering a critical section of the code while a thread is already processing it. While locks are simple, effective, and overall awesome, they come with some downside, like potential deadlocks where 2 processes are waiting for each other indefinitely, each holding a resource that the other one needs. Therefore, a deadlock. Next up are the atomic operations. Atomics are operations that are completed in one single step. Going back to our kitchen example, imagine if you could add a pinch of salt to a dish with no chance of interruption. Atomic operations ensure that tasks like incrementing a counter are completed without any interference, making them faster and less prone to errors than log-based applications. Last up, let's talk about condition variables. Condition variables are a bit like a signaling system. Imagine if you're coordinating a group project where certain tasks depend on other tasks finishing first. A condition variable allows a thread to sleep and wait for a specific condition to be met before it continues. For example, a thread might wait for another program to reach a certain state or complete a task before it proceeds. These tools help prevent race conditions. Race conditions are situations where the output depends on the sequence or timing of uncontrollable events, leading to unpredictable results. Let's talk about a few real-world applications to illustrate why all of this matters. For example, in video streaming service, synchronization ensures that video data loading, like buffering, and playing happens smoothly without stepping on each other's toes. Just like in our kitchen, when proper timing ensures that all dishes are prepared and ready to be served together, perfectly cooked. Another application would be at busy websites, handling thousands of user requests at the same time. Here, concurrency allows the server to handle multiple requests in parallel, while synchronization ensures that each transaction is processed correctly and without any interference. Thanks for listening to this episode of the Technical Interview. Please share this podcast to other people who are getting started for their interviews or would like to learn more about various technology topics. Thank you. Till next time.